Okay. All right, everybody, welcome. My name is Gloria Edwards, and I'm the director of the Southern Rockies Fire Science Network, which is a member of the National Joint Fire Science Program. Ourselves, along with several other fire science exchanges, are hosting a webinar titled Spatial and Temporal Trends in Causes of Human-Ignited Wildfires. This webinar is being recorded and will be made available on the Northwest Fire Science Network YouTube channel within the next few days. Everyone who's registered will receive a follow-up email with a link to these recordings. Please feel free to use your computer audio or call in using your telephone. You can refer to your registration email for your call-in number. Your microphone, as you joined, is muted as we are in webinar mode. Captions are made available by using the CC button on your menu. You may also enable the full live transcript or hide captions from this menu. Since we're in webinar mode, we'll be managing questions and answers in the Q&A box. Please put your Q&A in Q&A. Please put your question in the Q&A box, and please feel free to put comments or links or other information in chat. Our facilitator, Autumn Ellison, is monitoring Q&A in chat, so we'll be taking a look at both. And please let us know if you're having any technical difficulties or if you want to share a resource related to the webinar content. We are self-money funded, so you're answering a generated survey after the webinar is crucial to our programming and our feedback and our planning for events like this. So please answer a short survey at the end of the webinar. Your responses are anonymous and will greatly help us with future programming. Again, this is recorded, available soon on the Northwest Fire Science Network's YouTube page, and we'll be putting links to all of those. And let me move forward. Here's our housekeeping summary audio recording chat box. Let us know if you're having technical difficulties. Captions are enabled. Q&A in the Q&A box. And please answer our survey. Oh, also, we invite you as you join to feel free to keep adding your names and affiliations in the chat box. It supports our programming, and we enjoy seeing who's interested and who's joining us from around the world, as well as domestically. A few words about the Joint Fire Science Program and your fire science exchanges. A lot of you know a little bit about us, but for those who may not, this is organized by 6 Western exchanges. I don't know if does my cursor show up, John? Great. The 6 Western exchanges of the Joint Fire Science Program Exchange Network. There'll be a webinar link. There will be a link to the Joint Fire Science Network in chat. These regional areas work to facilitate the exchange of fire science information and knowledge between researchers, managers, and communities. The boundaries that you see are guidelines. People go to the fire science exchange that fits their needs or their knowledge needs. And these are basically encapsulating general fire ecozones. Southern Rockies works closely with the Southwest, since the Southern Rockies geography generally goes into New Mexico. And the purple thumbnail we see here is the Black Hills. You can see that the goal is to accelerate awareness, understanding, adoption, and implementation of readily available and credible wildfire science information. Our mission is to increase the awareness and understanding and adoption of this field knowledge and science and implement it to increase our sound land management decisions. Our audience, people who are interested in wildfire, managers, practitioners, scientists, community members, collaboratives, landowners, non-governmental organizations, and much more. You can see some pictures there of in-person, can't be beat. Webinars and digital methods are the runner-up, and we're glad to have our capabilities with webinars. Venues, we use a wide variety of resources: syntheses, research briefs, videos, podcasts, in-person conferences, meetings, field tours, workshops. So we invite you to join our networks as the links are dropped in the chat. If you are learning from and enjoy what you're seeing today, join us for even more wildfire information and a greater network. As we all know, there have been a lot of extremely devastating fires. We'd like to address any trauma that topics that our speaker may be addressing that may be generated. We're asking everyone to consider a trauma-informed approach in how we all engage today. This means we're taking care with images, words, and the tone that we use to maintain an environment that considers the safety and well-being of everyone here. By being respectful with your own words and tone when you ask questions or provide comments, and take care of yourself if you need to step away or doing what you need to maintain your safety and you feel you need to do that at any point. If you'd like to learn more about trauma-informed approaches, you can check out the Oregon State University Extension Trauma-Informed Toolkit, and the link to that will be provided in chat. Again, another pitch to please fill out the survey. Please put in comments about how you may be applying this knowledge so we can share that with our broader community and our funders. If you're a student attending, please share how this is enhancing your learning. And with that, I'm going to stop sharing and hand this over to Dr. Abatzoglou to share his recent Joint Fire Science Program funded research.
Yeah, thank you, Gloria. Thank you.
Thanks, John.
Yeah, thanks. And thanks to Joint Fire Science for the support and you all for organizing this. I am going to talk a little bit about sort of the title of this session, which was sort of the spatial and temporal trends in human ignited fires. But I'm gonna like go off and talk specifically about one of the fire prevention measures that we looked at. And part of the broader set of talks this week are coming out of a project for us to sort of assess the efficacy of various fire prevention measures. Obviously, we know that human-caused fires are a problem, given what we have seen so far this year in California, with them all being human-caused fires. There's obviously more that can be done, particularly to limit these fires during critical fire weather conditions where we're gonna result in significant problems. So to that end, I want to talk about red flag warnings. You probably are all familiar to some degree with red flag warnings. I asked AI to make me a couple images, and I'm not sure these are red flags, but you know, it was an attempt. We really want to see, do red flag warnings help mitigate human-caused wildfires? I will say first off that red flag warnings were never designed to act as a fire prevention measure, right? They were really more well designed to help guide fire suppression, right, resources, emergency management. That being said, they are probably one of the most visual sort of cues that the public may be receiving in terms of critical periods of fire weather. So take you on a little bit of a journey here. And you know, the short run is that we didn't find these were super effective, but there's also some interesting pieces along the way. Okay, forward. So, right. So I want to sort of talk through these three items here, right? Red flag warnings, you know, do they help aid as a fire prevention message system? They're sort of an early warning system, perhaps, obviously important for fire resource and fire management. What about the fire prevention side? Given the great data sets that Karen Short has put together, we have a comprehensive set of fire ignition database by various causes. And one of the interesting things that I think is sort of novel, what I'll show you here, is that we do see different responses in terms of the potential efficacy or responses in terms of fire counts from different causes coincident with red flag warnings, which might suggest that there are some benefits for certain fire causes, other causes maybe not so much. Okay, and I think I will very briefly talk about some of the challenges and recommendations for improving the efficacy of red flag warnings, acknowledging that the Weather Service, National Weather Service, has sort of already moved into sort of modernizing the approach. And I'll show a couple examples of that, given some of the red flag warnings that were put up during leading up to the January 7th event in Southern California. Right. So we have a lot of different warning systems that are out there. Our red flag warnings are, again, they're one of the tools that the National Weather Service has for issuing warnings. We also have various other measures that you might see out there from Forest Service, right? Other agencies. All these warning systems are out there, and hopefully these warning systems are designed to reduce harm, right? Improve situational awareness, et cetera, et cetera. There's a lot of different systems though. And so I think one of the potential challenges is, how do we make sense of all the different pieces of information that come out, especially given the era that we're in, where we're bombarded with lots of chaos all the time. Okay. So red flag warning, just so everybody is familiar with it, this is one of the vehicles that the National Weather Service has for issuing potential periods of heightened fire risk. And these warnings can be issued within 48 hours of an event starting, right? Prior to that, you get a fire weather watch, right? If there's something that is going to materialize, that'll be 48 hours, more than 48 hours ahead of the event. And what I will say is that there's a set of very complicated, it's a complicated set of sort of matrices that different weather service offices, fire weather zones use in terms of thresholds that are considered for the issuance of a red flag warning. I won't go through them all, but I'll show you a couple examples. It's often some combination of dry fuels along with things like high winds, right? You might see low humidity, and in some regions, lightning, particularly dry lightning, ends up being another trigger for the issuance of a red flag warning. These things vary a lot from place to place. Okay, so I wanted to give you an example here. This is actually, I was noticing that the Weather Service in Los Angeles had sort of been modifying their issuance of red flag warnings. This was from Friday, January 3rd, right? So about 4 days prior to the onset of the Palisades and Eaton fire. And realistically, the Weather Service in Los Angeles had sort of highlighted that this event was very likely. Magnitudes might vary up to a week in advance. They were on it quite well. And you can kind of see here, they have a lot of nuance with this. They actually I've seen them piloting this system where they're sort of highlighting, critical fire weather conditions. This is a fire weather watch because it's more than 48 hours ahead of the event. And then they're also sort of codifying sort of a magnitude of the event. And so at this point it was major. You can kind of see here, right? They're sort of highlighting wind gusts, possible very high wind gusts, low humidity, dry vegetation, right? The trifecta for if an ignition happens, it's going to be a challenge, right? You're going to see the potential for extreme fire behavior, challenges with initial attack success, etc. And then this was, this is the same sort of system for issued on January 8th. At this point, we had already the Eaton fire and the Palisades fire occurring. I think we might have seen a couple more fires that day. And yes, this was definitely a red flag warning, extreme, same general sorts of things, right? So there's a little bit of nuance. I think that I've already seen some changes out there, and there's more changes underway. I'll highlight that a little bit here later on. Okay, so key point is that a red flag warning is issued for sort of a combination of dry fuels and weather conditions that would support some combination of fire ignition or significant growth, right, of a fire, making it potentially challenging from a fire suppression perspective. I'm not gonna, there's a little bit too much detail in here, but I'll just highlight here, an example from the Pendleton office for all their fire weather zones. Lightning, right? If lightning is forecasted coincident with dry fuels, and you don't get more than a 1/4 inch of rain, right? That might be enough to issue a red flag warning. So lightning is really the trigger here, lightning with dry fuels. And then another example from the Portland office for certain fire weather zones. Some combination again of like low relative humidity, 35% or less, and wind speeds of, in this case, actually fairly low wind speeds, but maintained for a long time period. So wind speeds of 10 miles per hour or more, gust of 20 miles an hour or more for about 4 hours in an 8-hour block. So lots of possible ways. And again, it's a complicated and messy system. I would not be surprised. Some of these things have changed through time a little bit. And of course, there's an effort underway to hopefully modernize a little bit of this. Okay. A couple examples of red flag warnings issued here for folks that do remember the Labor Day fires of 2020 that impacted much of the Western Cascades in Oregon. Here's one issued by the Weather Service in Medford, right, at 10 in the morning, right? And their forecast here is for gusty winds, low humidity, poor overnight relative humidity recoveries, and east winds, of course, with dry fuels, right? So that's obviously a hot, dry, windy one with dry fuels. And then another example here from Siskiyou County, where really it was more about lightning, abundant dry lightning on dry fuels. Okay, so again, lots of possible ways you can put these sort of red flag warnings together. And again, the idea behind these red flag warnings is that they were sort of developed in a way that the Weather Service could coordinate with fire agencies. The primary reason behind them was to prioritize resource allocation for fire suppression, also for firefighter safety. This probably be really true for windy conditions. Certain sort of fire suppression tactics may be not recommended under critical fire weather conditions. The key point here is that the public is typically not really considered, right? But red flag warnings are perhaps one of the most public-facing fire potential issuances that are out there in the U.S. We have other sort of systems as well. That being said, what we do also have is we have begun to see the National Weather Service in their text forecasts, right, and in some of their messaging, to mention that when there are red flag warnings, that they urge caution of people in terms of potentially starting a fire. And this is way too small up here, so I'm gonna just tell that story. We had here in Central California, there was a red flag warning issued on July 4th for the foothills of the Sierra Nevada, and it was effectively some windy conditions, right? Windy conditions, warm, dry enough, which is not too much of a surprise. But you can kind of see here, and I'll just read it. It says, any use of incendiary devices will greatly increase the risk of quickly starting fast-spreading grass fires under what are typically low to moderate wind speeds. So outdoor burning is not recommended. And it turned out that during this particular event, we actually did have a fire burn near Mariposa, impacting communities, threatening the town of Mariposa. And yeah, July 4th is not a great day to have a red flag warning, but it was certainly part of it. Right, while red flag warnings never intended to sort of consider the human perspective of starting fires, it's possible that there's some potential link here. Okay. Red flag warnings are issued across the U.S. And this is you've probably all sort of seen this like at a factory number of days since the last person had a disaster. This is a map that's essentially showing the number of days since we had the last red flag warning by offices across the U.S. And of course, we can see here in Southern California, it's been 8 days since red flag warnings were issued in the Los Angeles and San Diego components. What's kind of fascinating is that this particular office that I don't necessarily know actually issued a red flag warning yesterday. So they're issued across much of the U.S. However, they are issued with very, 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 very different frequencies. You can see some of these offices, it's been 2,400 days. So I don't know, that's 8 years. That's a long time since the red flag warning. Not necessarily a thing everywhere. Okay. So I'm gonna walk you through a paper that we published, and I'm also happy to share the paper with folks if you do want to reach out to me afterwards. I can give you a copy of it if it's of value. But I'm walk you through some of the features here. So what we had was we acquired data on red flag warnings across the Western U.S., um, which you can see the domain defined here. For the period 2006 to 2020, the red flag warning database that we had access to only went back to 2006. We were using the FPA FOD Karen Shorts database, so that was sort of limiting us to 2020 at the time. And this is showing us the number of days per year where a red flag warning is active, right? And I'll say that red flag warnings can be issued for, one day and extend for several days. So this is really a true count of the number of days per year that these red flag warnings are active. You can see that there are some hotspots of red flag warnings. For example, Eastern New Mexico has a lot of red flag warnings. The average is 30 days per year. Places like Southern California as well are also a hotspot for red flag warnings. And then there are other places where red flag warnings are, not very frequent at all. And what's interesting is that the Central California here is not a place where there are a lot of red flag warnings. I will say that a lot of this is also irrigated agriculture, and that might be part of the matrix here. But again, there's different criteria in terms of issuing red flag warnings from Weather Service office to Weather Service office, and then these smaller polygons here are what we call fire weather zones. So this is not a map of fire potential, it's just a map of how often these red flag warnings are issued over this 15-year period. Okay. Yeah, so we wanted to ask a couple questions. First, do the number and type of ignitions differ significantly when we have red flag warnings versus from adjacent days, right? And I'll get a little bit more to sort of how that looks here in a bit. And then secondly, right, is the probability of an ignition becoming a large fire contingent on a red flag warning? Do we see the conditional probability of ignition becoming a large fire much higher or lower when we have a red flag warning? You probably know the answer to that one, but we'll walk you through what the data show and some of the patterns as well, because there are some differences in the patterns, especially as a function of human ignited fires versus lightning ignited fires for that second one. Okay, so very briefly on data and methods. I don't want to walk you through too much detail, but again, we had this database of red flag warnings for 15 years, like I mentioned previously. We had also a database of the occurrence of lightning, right? With the red flag warning database, we don't know exactly why those red flag warnings were issued, right? In the archives, there's sort of information about maybe a combination of low humidity and strong winds. We couldn't screen through them all. And so we did have a database of lightning, and that was used to discriminate red flag warning days where lightning was present in a fire weather zone as a proxy for, possibly issuance of red flag warning during lightning days. Okay. We actually looked at what we call pseudo counterfactual days. Okay. And so the goal here was to, again, we wanted to compare whether or not we saw a difference in the number of fire counts on red flag warning days versus non-red flag warning days. And it's a little bit difficult. So this is why this is not a true counterfactual, because, a true counterfactual would be that we had the same weather, but the Weather Service just did not issue a red flag warning. And clearly that doesn't make a lot of sense. So what we did here is we effectively used these pseudo counterfactual days as days that were adjacent to a red flag warning, but not within a day or during the red flag warning. So it's kind of a like pre-red flag warning, post-red flag warning, maybe similar sorts of times of the year, similar sorts of longer lived fuel moisture, 1,000-hour fuel moisture. ERC is not terribly different, but very different weather triggers in terms of wind, lightning, etc. The sorts of things that are often really flagged when it comes to red flag warnings. I mentioned the FPA FOD database. We aggregated counts to the fire weather zones. And then, right, there's lots of different sort of types of fires in there that many people are familiar with. We set out defining and I will say defining because I think there's lots of ways to define this. We set out defining different types of human-caused fires. And this will relate a little bit to the potential efficacy for ignitions to be limited during red flag warnings. So we had what we considered elastic causes, and these were fire types that we might consider to be associated with short-term behavioral choices. For example, if we had knowledge of a red flag warning, maybe we would not engage in, maybe that would be not a good day to do debris and open burning, right? Maybe that would not be a good day to have a campfire, right? Not a good day to start a fireworks or shoot firearms. Those sorts of short-term behavioral choices. And then the inelastic ones are um, effectively items that are somewhat maybe not necessarily as easily swayed or influenced by the issuance of a red flag warning. So things like infrastructure, right? This has to do a lot with electrical lines, and there's an obvious example that's a counter to that, which we'll get to. Things like arson. I don't think that arsonists are, gonna go, today's not a good day to start a fire because it's a red flag warning. I don't think that they're using red flag warnings to their advantage, but I don't know. Equipment, maybe not. Railroad, some of these sorts of things that are associated more with habitual behaviors. I think smoking is in this as well, if I recall correctly. And then lastly, we define a large fire size very, very generically as a fire that has an eventual size of at least 100 acres. Okay. Enough of the data and approach. I want to show you some of the results here. So first of all, just some statistics on how the disproportionate number of fires that occur on red flag warning days. I showed you that map of the number of red flag warning days in the Western US, and it's, varies quite a bit, place to place. The take-home messages here is that we see about 8% of all wildfires. And about 22% of all large wildfires start on red flag warning days. Red flag warning days are only about 3% of all days if we sort of aggregate across the entire West. So that's giving us this idea, and that's that red line here just for reference. That's giving us a hint that, yeah, okay, there's more fires that start on red flag warning days. It's probably not a huge surprise, right? You can see maybe some interesting differences if you sort of look from sort of the top to the bottom. Large fires, obviously, 22% of all large fires start on red flag warning days. Okay, lightning makes sense as well. And then power is utility electrical line. Those are obviously very prominent on days with red flag warnings. And other things like debris burning is here at the very bottom, which, by the way, may be due to the fact that debris burning is happening, possibly actually not during the red flag warning season, right? There is a strong seasonality to when red flag warnings occur, and that might be a little bit off in terms of the patterns of when debris burning happens, or at least debris burning fires happen, and when red flag warnings happen. Okay. Yeah. And so, as I mentioned before, we were able to parse out from all the days with red flag warnings. We can look at the days where there was a red flag warning and lightning, right? And so we define these as sort of the red flag warning days that are coincident with lightning. And this is not a heck of a surprise either. And I will remind us that um, not all sort of weather service offices or fire weather zones actually have, to my knowledge, have dry lightning codified as one of their triggers. Okay, I think this is much more prominent in the sort of the northern half of the West and less prominent in the southern half of the West. But the take home here is that lightning ignitions are about 5 times as frequent on red flag warning days with lightning. And again, we're comparing here to the red flag warning days versus the adjacent days. Okay, the days that were a few days before, a few days after red flag warnings. And again, much more prominent lightning caused fires. Everything else in terms of the other human caused fires, not really much, right? It's kind of all over the place. Some of these are significant, but nothing super obvious with that. Okay. So that makes a lot of sense. And I'll show you a few of these maps. Anything that's hashed here is not statistically significant. So much of this red here, pretty strong signal. Okay. So this is a little bit maybe more interesting thinking about the human causes, right? And again, these are the red flag warning days where there was not lightning, or yeah, when lightning density was basically zero or incredibly low within a fire weather zone on a day where a red flag warning was active. And our message here is that, by and large, most causes, and just look at the human causes. The natural one is whatever, a little lower, not a big deal. Most of the human causes, we see elevated numbers of human-caused fires during red flag warnings versus the adjacent days, versus these pseudo counterfactual days. And I think the number here is, on the whole, it's about 33% more human ignitions on these red flag warning days than these counterfactual days. You can go through this and sort of, parse out that there are some categories that are exceptionally high. So the electrical power, we see about over twice as many fires from that source on these red flag warning days that are not associated with lightning versus the pseudo counterfactual days. And then likewise, yeah, railroad, smoking, these are some of the higher ones here. And inelastic is sort of the combination of the categories that we considered. So I think it's equipment and arson as well as part of that. So the inelastic causes, on the whole, we see that they're about 36% higher. The elastic causes, the ones where maybe, possibly some of the short-term behavioral choices, where a red flag warning might actually dissuade people from undertaking debris burning, right? Undertaking fireworks. What else in here? Um, Recreation, campfires, those sorts of things. We find that this is still higher, right? So we still see more fire starts on red flag warning days than the counterfactual, but it's not nearly as high as these inelastic causes. What I will say is that as well, like, red flag warning days have the ingredients for any potential ignition to materialize and catalyze itself as a real ignition, right? Winds are higher, humidity is lower. So that's why these sort of pseudo counterfactual are not true counterfactual. I think we should generally expect fire currents to be a bit higher. Just keep that in mind. Okay, and then I wanted to show you here. These are the same. This is the same sort of information, but I'm here looking at just elastic fires on the left and inelastic fires on the right, and we're just mapping it out, right? Because you could certainly sort of throw all ignitions into the same pot, get some statistics, and this is really to sort of demonstrate or visualize the consistency of these patterns across the different geographies. And the main point is that, for most of the West, we don't really see a significant difference between the number of what we would term human-caused elastic fires on red flag warning days versus non-red flag warning days, right? That's most of the hash stuff here. Obviously, exceptions are apparently Colorado and then Southern California, and maybe here in Western Oregon, Western Washington. But you can clearly see for the inelastic causes, we have a much broader area of elevated and significant numbers of inelastic fires during red flag warning days versus those counterfactual days. So that adds a little bit of confidence to sort of the statistics I showed you previously. Yeah, okay. And then the last piece here is to sort of look at whether the conditional probability of an ignition becoming a large fire, right? And again, a large fire is at least 100 acres. What is the odds of a ignition becoming a large fire if that ignition happens on a red flag warning day? And again, the same thing, right? So the left-hand side here, these are, oh, and I should say these are all human ignited fires. Okay, yeah, is that what I did here? I can't remember here. It says human ignited fires, but actually I think it's all fires now that I'm really thinking about it a bit more. So The key point here is if you look at the red flag warning red flag warnings where there was no lightning present, which is realistically probably a red flag warning issued for the potential for wind and low humidity, some combination thereof, maybe some instability, but no lightning. There is a much higher likelihood of an ignition becoming a large fire, right? Overall, it's about a 30, a third higher chance of an ignition becoming a large fire when we have an ignition during a red flag warning. So, like, if you combine these two together, so I showed you previously that for a lot of these causes, we have an extra amount of ignitions during red flag warnings. And now I'm also showing you here that if an ignition happens during red flag warning, there's a much higher likelihood it becomes a large fire. So that's, yeah, I mean, that's not too much of a surprise for probably most of us, but it bears out in the analysis. I think what's interesting on the right-hand side, so these are the red flag warning days that occurred with lightning. And there's not much going on here, right? There's a few regions that are statistically significant, but these are not places. It's kind of across the board. I really wouldn't read much into this. What this is telling me is that by and large, the biggest factor for fire activity during red flag warnings with lightning is just the sheer number of new lightning caused fire starts, right? And I think the numbers I had before was about a 5-fold increase in the number of lightning caused fire starts when we had a red flag warning coincident with lightning. Not really significant here in terms of those fires becoming, larger on when they start on these particular days. Okay, so it's more about the number of fires versus them becoming a extremely large. Lightning caused fires are much larger than human caused fires, though, in general. So that might be washing things out a little bit there too. Okay, so I wanted to sort of tie these things together. We set out maybe hoping that we would see something to the end that red flag warnings potentially can help mitigate human caused fires. And the answer is not yet, right? We don't really find strong evidence for that. As I mentioned, we have these pseudo counterfactuals, which are realistically windier, drier days. And so that might be biasing some of the results a bit. But there's also other reasons why maybe red flag warnings are not an effective tool. Again, they were never really designed to be an effective tool. But, they are one warning system along with other various warning systems that are out there. It's possible that they're not reaching the intended audience, or audiences are apathetic, right? I think in my first map I showed you, there are places that average about 30 red flag warning days per year. At some point it's like, is it The Boy Who Cried Wolf? I think that's the right one. It's possible that people become apathetic or just ignore the warnings at some point. Red flag warnings are not the only fire warning system that's out there. Other systems exist. Maybe those systems are more effective. Maybe these warning systems confound messaging, right? And I don't have the answers on that side. I am just sort of speculating on what may happen here. Inelastic causes are also possibly challenging, right? Some of them are very inflexible, right, to actually mitigate the potential for limiting human caused fires. The exception, of course, is the public safety power shutoff program that was started with San Diego Gas and Electric and has spread throughout California and other parts of the Western U.S. And that, of course, in that system, red flag warnings are not explicitly used as the only measure in the issuance of a public safety power shutoff. But it's possibly one ingredient. And the goal there is to, of course, limit the potential for utility caused wildfires when we have especially dry and very windy conditions and dry fuels. And so it is possible, and we didn't have a long enough database to look at this, as to possibly we have seen maybe some changes in this response between red flag warnings and the number of human caused fires through time. It's with a 15-year database, it's probably a bit tough to do that. On the issue of audiences being apathetic or red flag warnings being super, super frequent. The National Weather Service has been rolling out a more tiered red flag warning system. They have been issuing, I think they've issued a dozen, maybe more now, because there were quite a few issued in the Los Angeles office recently, but issuing essentially what's called a particularly dangerous situation, which is essentially ratcheting up a red flag warning. So it's, in other words, it would be a very, very severe red flag warning. They issue particularly dangerous situations for other weather hazards, but this is possibly like escalating that it's not just a run-of-the-mill red flag warning, it's more serious. Again, are those things going to actually have an impact? It's unclear. Um, it's also possibly an interesting question as to whether, after we see these sort of catastrophic fires that we've seen, for example, this month in Los Angeles, do people become more apt to, not start fires during extreme fire weather or not? That's a fascinating question as well. I wish we had the data to sort of test that out, but won't happen today. I think that's all I have. I'm happy to entertain any questions that folks have, though. Stop sharing.
There's
Fabulous.
a few questions in the Q&A box. Or yeah, Gloria, I'll let you take it over.
No, go ahead. Autumn is our webinar facilitator, and I just want to take this moment to introduce Erica Fleischman, who's also a panelist and a researcher, a co-researcher on portions of this Joint Fire Science Program research project. Erica, feel free to activate your video, and she's posted some answers to some of the questions in Q&A. Autumn, did you have anything else to add before we launch into Q&A and some comments?
Nope, you got it, Gloria.
Okay, all right. Well, if I stumble and, if you have anything to add, let me know. John, that was really interesting. And it was very interesting that your results also kind of confirmed what we were finding in a publication that we did with Southern Rockies Fire Science Network, where we did a canvas of fire practitioners right after the 2020 fires. Rex Thompson addressed it as well. Red flag warnings and fire danger ratings can be confusing, that there's a science and conditions that's projected for the public, but not really what they should do. In Colorado, I would say, Rex, I'm not sure where you are, but there's a lot of resources that advise what steps people should take and definitely what they shouldn't do. But it's very, very confusing. Even between municipal fire departments can have different alert ratings. Real quick, Matthew Engring asked, how is this information from this webinar series being shared with congressionals and state governors? Just on the Fire Science Exchange side, I would say that we make great efforts as best we can to recruit policymakers in our in-person and webinar series and events, as well as have them be on our list for our newsletters. It's difficult since we're minimally staffed across the country to develop collateral materials or hard copies or infographics for all of these. We are in talks with Erica and John about maybe using some of the funding to make this very accessible in terms of infographics or one-pagers. You're in Arizona, great. North or south, you can toss that in. Porfirio Chavarria, he's an old buddy from Santa Fe. Welcome, Porfirio. Was there any analysis on existing fires during red flag days? Were the fires to red flag? And we have about 15 minutes, so we have a good bit of time for discussion.
Yeah, that's a great question. We didn't do that here. We just looked at it. I think we were mainly focusing on ignitions. It would not surprise me though if we see these blow up days during red flag warnings. That would be fascinating to look at using different sorts of databases. You know, I have also seen a tendency for sort of prolonged red flag warning days when we have active fires going in certain geographies. It would just require looking at a different sort of database, but that's a really useful question as well, especially when it comes to the fire dynamics.
Okay, that would be something for future research. Bruno, curious if you've seen any indication, oops, it moved, of temporal variability in messaging efficacy that could have attributed to recency bias. At National Weather Service Boulder, we've certainly noticed an increase in volume of public and media engagement ahead of severe red flag events. Yay. Following the 2021 Marshall Fire could impact public preparedness. I'm assuming you have access to these questions and you can
I can
take a
see
look
that.
at
Yeah,
that.
that's a really good question, Bruno. I think that I want a longer database, but it would also, I think, that'd be really fascinating to look at, maybe on a case study. If you were to look at the sort of the Boulder region post, do you see a response in terms of the number of ignitions in general, human-caused ignitions in general, pre and post the Marshall Fire, responsiveness to red flag warnings, pre and post pre and post sort of these fire disasters? Yeah, I would like to look at that question. I think my statistics would be not so great, but we would hope that, you know, some silver lining would come out of events like this. You know, we're looking for some good news that come out of disasters, and maybe it is that we become more responsive. And the tendency, though, I think what I would be concerned about is at some point we become complacent, we forget about it, and the cycle repeats itself.
Nathan from Santo Domingo. Welcome, Nathan. Glad to have you from Santo Domingo, New Mexico. I'm assuming it's New Mexico. He asks again some of the existing fire acreage, but do you have any analysis on acreage growth during red flag warnings or some other method to take in consideration? I believe you answered that no, that wasn't a component of this.
Yeah, I don't have
That would be
that.
interesting to look at.
But that's a useful, I mean, there's some neat databases, I think, to sort of look at that particular question. And yeah, I'd have to imagine we get some big days during red flag warnings on
Oops,
existing fires.
we're answering live. I need to contact that we've answered live. Hold on. Technical moment here. Do you have any, Liza asks, do you have any recommendation? This is getting into the meat of things, how to modify red flag warnings or public service announcements, I think she means that,
Yeah, this is
to reach public or elastic causes.
yeah, the particularly dangerous situations.
Thank you.
Yeah, I think, you know, I think the one thing, and I had a master's student who looked a little bit at sort of red flag warnings in the Northwest specifically, and we had a little bit of interaction with some of the Weather Service offices as well. There's a lot of maybe inconsistencies in sort of how sort of the fire danger rating system is used. Things like, you know, considering, I don't know, ERC, some measures of ERC or fuel moisture, things like that, I think could be sort of harmonized across regions a little better, and that might help a little bit more in terms of, you know, improving the ability to issue red flag warnings. In terms of public messaging, I don't have a great idea. That I think that's an open question for everybody about how we better do this.
Consistent messaging, and
Consistent
you know,
message.
we have the red, yellow, green, and then we have this 1, 2, 3, 4, 5, and
Yeah.
green all the way to your purple extreme, and then that changes within municipalities.
True. Yeah.
That's a consistent, and then the federal system has their own. So it would be interesting if the National Fire Academy and the National Fire Service came out with something practical and usable for across the board, which would be really great. Or maybe LA. Giles Troughton asked a couple questions I'm sure that you can see and address. Utility providers are not currently proactively initiating public services appropriately, and what additional, which we're touching again, recommendations, interventions would be appropriate.
Yeah, I think the first question, I don't know. I think it's one thing that I would say that we are working on a little bit right now is in California, at least, we do have a database of all the PSPSs that have been issued since 2013. And, we are curious to see if there has been any sort of, significant drop off in the number of utility caused fires as a result of PSPS. The PSPS is
And PSPS stands for,
Public Safety Power Shutoff.
yeah, I'm an anti-acronym kind of person.
Yeah, and that one's a tough one because if you try to do the plural of that, you just sound like Daffy Duck or something. What happens? How red flag warnings are sort of baked into a utility deciding on a PSPS is unknown. They're all a little bit different. Some of them are public facing, some of them maybe less so. It's a really useful question in terms of are these working? How can they work better? The second question, I don't know how possibly, so the malicious activity, that's a difficult one to do. I do know that in the fire prevention literature, there is something in there related to, exactly, increasing law enforcement patrols, limiting access to certain areas. I know at least in California in 2020, after the chaotic fires, all the Forest Service units were closed in the state for an extended period of time. None of this is great, but that may be something that could be done.
Bruno Rodriguez added that he certainly agrees the terminology can be confusing, but I think he means to say a marked shift, maybe progress in messaging strategy on the National Weather Service side for red flag warnings with more emphasis on specific actions. So we probably can use a lot more of that. And Gwen Bivens asks, wonder if further expanding and publishing red flag warnings with various levels of severity and additional details is actually making people more confused. So we're getting back to a consistent issue facing all of us, that there's a lot of different systems, there's a lot of different designations, different recommendations. What would you like, is my question, and I invite Erica or Autumn to step in. We have just a few more minutes and the survey will post soon. Please, please, please fill it out. It's really critical for us. And please let us know how you might apply this or take some of this and do your own actions to simplify the system. Or if you're a student, how this enhances your learning. What would you, John and Erica, what would you like managers, the most important thing, two things that you would like to see them take from this and change? In a perfect world.
I'll jump in. There's nothing, I'm not going to dictate to a manager how to do their job. So I don't feel comfortable saying change in this particular way. I don't know their constraints. I don't know what they're seeing in their area, what they have tried and found effective or not effective or what have you. One thing that was brought up in the questions and that we've found is that there are some sources of data that would facilitate some of the analyses that people are asking about that simply don't exist. Or they don't exist comprehensively across the Western United States. So for example, it's often not possible to compile data on when fire restrictions were issued and rescinded and where. That is not a criticism of managers, but if people would like data, would like analyses related to fire restrictions, working with their respective agencies and thinking about, is there a way that would not take a tremendous amount of resources to standardize reporting, to facilitate reporting so that that information is accessible, would, in my opinion, be very helpful.
Any thoughts, John? There's a couple other questions posted I wanted to get to before we sign off in a few minutes.
Yeah. I mean, I think there's some interesting questions in here about if we do have these new sort of systems and like a ratcheted up version of red flag warnings, might that make people less, actually even more apathetic to the run-of-the-mill red flag warnings? I think the work that we've done here just puts some numbers on the table, possibly highlights that maybe red flag warnings are less effective for certain causes, which sort of makes sense, maybe slightly more effective for other causes. I think we do need to figure out how we can better communicate, and that's going to fall in the realm of the other expertise, not expertise that I
Okay.
have necessarily.
Okay.
Yeah.
Well, you're certainly providing a vast amount of data and statistical relevance to a lot of the information that's already out there. Liza also has addressed something that I'm seeing more and more come up is homeless cause fires, fires caused by the unhoused. And I'm seeing a lot of questions about that. There has been some research done. I believe it was in Northern California. It was at the Association for Fire Ecology. There's some graduate student or municipal research that's trying to address the causes for homeless cause fires, which some of the information from municipalities goes out and says, don't use any fire at all, but they need fire to stay warm or cook food or, maybe even get rid of trash or something. So that's becoming a field of study in its own.
Absolutely, yeah. And this is one that if those fires are happening, sometimes they're happening pretty close to human settlement and they become an issue. We need to find a way to help all the communities out.
Yeah. But you didn't include that in any of your data.
No, I don't know where that gets codified in the FPA FOD database.
I'm not sure it does yet.
It may not, yeah.
Erica, I think, addressed that on Monday. That's like in one of the categories.
Yeah.
Have you seen increased, or do we have information about increased incident responses, deployments, or preparation on red flag warning days? We're sure, yes, they probably do increase. Were any portion of those large fires actually prevented from getting even bigger to increase response readiness? Is our forecasting working in terms of deployment?
Yeah, I mean, I definitely seen this during potential for dry lightning, where there's staging of fire suppression agencies in locations that are potentially subject to dry lightning. I guess the answer is we would hope yes. I have no idea how to actually analyze that. But that's a really useful question, very different than the one that we were looking at here. But right, I mean, that's the intended goal of these red flag warnings, to sort of assist with with fire management, to make things more effective, to also not harm fire suppression personnel during especially windy conditions.
We're coming up on time. I just want to address just a couple of other things here. Kate and Dan both address some social science. This next step involves social scientists. Who are the social scientists working the public interpretation? And are there variances on historical arson, which can be local? Some of these questions, Erica, if you can address, I believe were addressed in your presentation on Monday. All the videos in this series will be posted to the Northwest Fire Science Consortium's YouTube channel. So all of these can be independently rewatched reviewed for answers to those. And I asked a question about arson, since how much ignition science really looks at separating out arson, and the answer was it was very difficult to tease that out separately as an intentional fire ignition from a lot of other behaviors. So that can also be looked at on our day one. Autumn, do you have anything else?
I don't. I just want to thank everybody for joining us over these 3 days, and especially thank you to our various facilitators and presenters, Gloria and some folks, Darcy and Carrie from the days before, and putting this together. There's a couple questions. We are recording this, and it will be on our YouTube channel, and everybody who is registered for any of these 3 days, if you've registered for that day, you will get an email with a link to that when we put it on there, as well as any follow-up resources that we've thought of to add. If we haven't gotten to some questions, we'll do our best to answer them in those resources. And thank you, Gloria, and thank you, Erica, for helping us organize this, and John for presenting all this important research today. There's obviously a lot of interest in it, and we could probably do another hour of Q&A probably, but yeah,
Yes,
just thank you everybody for
all the
everything.
attendees. This is your network. Please feel free to reach out to Autumn or myself or other Fire Science Exchange networks in your area. Thank you everyone who attended from far and wide and fill out the survey. Have a good day.
Thank you.
Thank you,
Bye-bye.
everybody. Bye.